Radians. What are radians? Up to this point, when you're talking about angles and angle measurements, you've been using degrees. Well, what we want to do is we want to talk about how to measure angles in radians. So when you think of the word radians, you should hear another familiar word, which is radius. So what we're going to do is we're actually going to have an activity to see how the radius of a circle is actually related to the measure of an actual angle. So for our activity, what we're going to do is we're going to start off just by drawing a circle. And we're going to draw the circle as best we can, like so. And then with the circle, we're going to identify the center of the circle. And then I'm going to actually draw a line that represents the radius for me. And I'm going to use R to represent radius. From there, I'm going to go ahead and take my string, and then I'm going to cut it to the length of the radius, meaning that I have it on the edge of the circle to the center. So I see I just have a little bit to cut off. And again, this is an approximation, so it's not necessarily going to be exact, but it will be suffice for us to do our little discovery here. And then the objective here is we want to figure out how many times this radius will wrap around the circle. And in doing so, what I'm going to do is I'm going to actually pick a starting point like so. And I'm going to make my radius kind of curve around the circle. And then mark my next spot. Curve around the circle. Mark my next spot. And I'm going to keep doing this until I get the whole way around the circle. And here we curve to here, and we're almost there. And what happens in this case, if I'm looking, is I see that it takes me 1, 2, 3, 4, 5, 6, and a little bit more to get the whole way around the circle.
6 and a little bit more. Well, that's interesting for us because that little bit more is a little bit more exact than you might think. And let's talk about that here. So if we take a look and think about what we did, what we measured was the distance around this circle. Well, the distance around the circle is referred to as circumference. And if we go a step further, we know the formula for circumference. Circumference is equal to 2 pi r. Well, what does that actually mean? Well, the distance around the circle is equal to 2 times pi radii. Or if we look at that value a little bit closer, 2 times pi is 6.28. So the circumference is equal to 6 and a little bit more radii. And that's why we ended up with a little bit more. And if we actually would take a look at another value, we would see that, all right, half of a circumference is equal to just pi radii. So if we look at our drawing, if we would extend this over to be basically half of a circle, we see that, a little bit more or really close to that 3 is where our half circle ended up, which makes sense because that would be 3.14 radii. So to kind of wrap things up, we can go back to our original picture here and start to make sense of it. And what I mean by that is, if you look right here, you see that value pi. Well, 180 degrees, or half of a circle, is equal to pi radians. And if we go a step further, well, half of a half, or 90 degrees, is equal to pi over 2. Because again, that's a quarter of a circle, or half of our half circle. And then finally, if I would take pi over 2, and then add pi to it, that would take me to 3 pi over 2, which is where that value comes from. These are our critical values for whenever we draw angles in standard position. And then finally, what you would see is this pattern kind of repeats itself, but we have a starting value of 0, but based off our discussion, we realized that this value of 0 radians could actually be 2 pi radians also.